deal with the constraints and tools I have. And what our studies had shown, that 50% of your carbon goals can be solved within 5 years. And I can actually say, and I've had talks with Dr. Tripathi on this, I've done a study for this campus, because we're saying, why isn't it happening here? And my best estimates, having now done 17 cities and campuses around the globe, we could achieve carbon neutrality in 3.5 years here if we really did the programs. Just of what we can do today. But how do we do that? That's the big question. How do we go across here? So, this is about operating models. The concept of an operating model is how you behave in your organization. How does the governance come across here? And it breaks into these 5 areas. How you're organized, how your value chains are, how you get things done and who you do it with, the people themselves, how your IT systems are behaving, and what decisions you make along the way. Traditionally, how companies and schools and governments think have been this. It's about shareholder value, and they understand CSR. If you're practical, it's about the shareholder still, but now instead of just CSR, it's about ESG. How do I manage this to make that movement over to environment, social, and governance models? If it's a value chain, it's extraction, and it's global sourcing. So do you use the term LCA at all? Life cycle management, so you understand that, right? You take something out of the ground, you transport it, you manufacture it, you use it, then you dispose of it, and maybe it goes away, maybe you recycle it. So understanding what this means and how do you get it globally sourced. Circularity, we'll talk about that. How do we create circular models in order that it just doesn't end up in a landfill and that it goes back to the system as best it can? And also proximity to source. The closer you build your solutions to where they need to affect, the better off you are, because you're eliminating the risk of how transportation is in other areas. So for instance, if you're going to solve that here, solve it here as much as you can, because localization is important. Physical security, diversity, it's about holistic wellness and about inclusion. Systems, IT systems, point solutions and dumb endpoints, so the sensors are there and there's dumb endpoints. It's more about smart connections and systems design now. And then profitable and being reactive is now has to move to be sustainable and actually be predictive, to forecast what's going on. What's the biggest challenge we're talking about worldwide right now, and the US is causing this issue? Tariffs, right? And the problem is, I'm not going to say whether tariffs are good or not, because I'll stay apolitical in this, but the question is when you have this volatility, nobody can predict what's going to happen, and therefore a business cannot plan what to do. Do I buy, do I sell, do I purchase, do I do contracts? So when you lose predictability, it makes it very hard to do anything. So when you create systems that allow you to model predictability and know what your choices are, it's a huge difference. So the themes that you will hear in discussions around sustainability come into you want regenerative futures. For me to do this, it has to be something that can work over and over again in the future, and it has key ideas that there's true measurement of ESG that has true social and governance on it. It's just not a couple of letters. You have decarbonization for a quantified priority. It is a priority to decarbonize. You have circular supply chains, and you have predictive, traceable, ethical points that you're doing. You actually have a human experience that people want to do this. They make the choice. It's just not forced upon them, because if they're not bought into it, they're not going to stick with it. And it deals with environmental health and safety, systems of systems. To me, in prejudice, everything is a system. If I can figure out what it is or how to break something down, I can start looking at complex things and make them doable and solve for pieces across there. And now we have to understand security and privacy in these areas. And then digital twins, they're there. Let's just say a digital twin doesn't have to be something pictorial and visual. It can simply be a dashboard. Or it could be just a machine, talking to a machine that understands what's happening, but I can mimic something in a digital environment to a physical environment and do predictive modeling, or see what's happening in the physical environment to understand better what's going on here. So, here's how to think when I said to Dr. Patton saying, I can get this done in 3.5 years, maybe 4 years, but I think we do it in 3.5. The first thing that you would think of is, what are the initial use cases? Break this down to a system. I took 4 things that are always the obvious ones for net zero. Electricity, emissions, water, and waste. So off of these 4, you're getting there pretty far. So within a year, you can actually identify those use cases, do some tests across here. The next wave is each of these then evolve into more complex programs once you're doing your proof of concepts. So I'll just take one, for example. Let's take energy. So my goal was to look at electricity and emissions coming across here. It results in programs that are efficient green building designs, efficiency measures, efficiency programs for energy, renewables. I start breaking those into actual programs like I showed for the emphasis ideas across here. I can do this for waste, I can do this for social. It comes in there. That's generally a 1 to 4 year program where you actually have implemented these programs. And there could be many more or there could be less depending on your situation. And what this eventually evolves to in true measurement is I can say, I'm now using renewable energies. I'm now doing GHG emissions in accountable ways. I now have provable points about I'm not wasting any water in my circularity system. I'm doing carbon capture. I have a net positive carbon emission. This can happen within a 5-year period. So it's breaking the problem down, and your first step is to come across here. Where you decide to take these and what programs, it depends. So just, we're setting up a pilot at schools right now at the campus here where we're taking the sustainability school building and we're going to make that the first building. We're already starting to do the measurements to determine what interventions and what's currently baselining. We're going to take 15 residences off campus, well, in campus, but private residences, and we're going to take one of the dormitories. And we're going to tell 15 meters, and we're going to say, let's start there. And let's build 3 dashboards, and let's get provable points, hit this goal, not in a year, but by October. So in October, hopefully I'm back here on stage saying, look at the dashboards. Look what's happened. Okay? So is anybody doing circularity? Does anybody know what circularity is? It's a very simple concept, but it's a complex thing to do. So circularity basically says things don't get thrown away, right? You use it and it just doesn't end up in a dump, or it's captured and it's got some kind of repurpose. And circularity, when most people think about this, they'll think of a physical object. So let's take your smartphone as a circular object. Somebody had to dig in the ground to get the rare earth metals, you had to make the plastic, you had to make the metal, you have this manufacturing process, you then use it. Hopefully you keep it longer than a year. In the United States, every year you get a new phone. It's crazy, even though the old phone still works. But then somebody takes it apart and they would have just dumped it or left it in a drawer. Now you would take it apart, take the rare earth metals back out, and hopefully build another device with it. That's a circular process. Probably a better example is the battery. So if you have an EV vehicle, the battery has to work at a certain level in order for it to be functional in your car. It will only last 7 years, more than likely, statistically. Do you throw the battery away? How do you dispose of it? Well, I guess a circular idea would say, no, I sell that battery to become a UBI backup system for this room, because it can still serve that purpose. So I think another way to reuse or recycle those components. So that's the general idea of circularity. What most institutions don't think about, though, there's actually 2 kinds of loops of circularity. It's just not physical examples like I talked about. There's also biological circularity. How do you treat your rivers? How do you treat your biodiversity? How do you treat your landfills? So it's actually understanding both the biological cycle and technical cycles when you do these kinds of plans through here. There's lots of science on this. It does not have to be invented, but it has to be creatively addressed. This is systems thinking and how to start breaking it down. So the challenge is you have this many complex systems. Like, how do I deal with those 5 organizational points? So complex ecosystems of both a physical and a digital system How do you match those together? How do I understand detecting the faults in the system? They're never straightforward, they're never obvious what they are. And how do I do the right interventions? How do I know what experiments to go, and then how do I know which ones to go forward with? So this is standard design thinking, and if this is pedantic for you because you're taking classes in it, I apologize, but this is where I start. In the top, you have a bunch of random things. Okay, that's what the shapes represent. They're organized, it's just a mass of things. And the first thing you do is you organize by type, and then ultimately you start constructing architectural frameworks that solve the problems. That's the basis for systems thinking, and then it can get a lot more complex, but every systems thinking, this is how it evolves. This is the base root for how you do it. So top part, I'm identifying the problem space, and I'm including causes and effects. I'm done understanding the opportunities for improvement. The mid-level, I'm considering what interfaces I have to deal with, what's the architecture, what's the data points, so forth. And the third, I'm coming with my organizational, my hypotheses. And this is where it really becomes interesting with research becoming both technical ready and then application adoption readiness levels to actually prove out the points of what you're doing across here. And doing those in a timely enough manner that anybody will care. So I'm going to give another example here. Anybody a Formula One fan? Race, watch car racing. So this is like the high-speed stuff. I'll show you a little video on it. It's my last video for today, so it won't take too long. But it is one of these proof points. It shows systems thinking. And what you're going to see is, if we look at these problem statements, and I'll show you how this applies. Passenger vehicles, they contribute up to 41% of transportation emissions. And it's probably the biggest issue in India right now, right? The biggest change. So how do you solve that? One of the solutions that we're using right now is using Formula One like a live living lab. The advances because of the amount of races that take place and how often in changing engines and experimenting with fuels, it becomes this wonderful way of saying what could work. How do I change it over to EV vehicles? How do I look at the right new safe formulas for green fuels? So we work in conjunction with this and other organizations to look at this, and it really creates an operation model that is set up for rapid innovation. It values the functionality over short-term profitability, and it has this ability to scale into the larger problem. So let me show you.
F1 has a new goal, developing the fuel of the future. By 2030, it's expected that there will be 1.8 billion cars on the road, with only 8% being electric. Other solutions are needed to reduce carbon emissions, and F1 is pioneering a drop-in fuel that could be utilised by vehicles across the world. The 100% sustainable fuel is unique, lab-created from renewable bio-waste, fewer emissions, more efficient, and saving power packed into every drop. For over 70 years, we've been at the cutting edge of innovation, developing the most efficient power unit and hybrid systems ever created. F1 is helping drive a green revolution for the entire planet. This is just the beginning of what is possible.
So this is an example of private organizations also looking, they see this is the future, and they have partnerships with research institutes because they need to understand what is green fuel and what's the next level of engine and how does all the elements of car design can evolve, and this becomes a real lab that can then put back into society to say, now how do I take EV buses and take advantage of these fuels? And this becomes very, very interesting with research to practicality across here as an example. And there are many others out there. So this is the breakdown. This is an algorithm test that I developed a couple years ago with General Electric and with Berkeley. And the concept is this. When you start with a problem statement, it's actually concrete. You kind of know what you have. So we understand what's going on. And as we start to explore ideas, it becomes less clear, and then it becomes clear again. And this, if there's any software programmers in the room, this also looks like an agile cycle, because we want to do it at speed. So in the beginning of your cycle, you frame out the problem, you design for what you have, you start to learn more, you form your insights, you start to ideate, and then you experiment. And your experiment could cause you to go in two different directions. You could say, I was really wrong, I'm going to pivot and go back to my loop and quickly identify that. But more hopefully, you say, I want to proceed with my experiment, and then I start a rapid build in a controlled manner, and I start looping those prototypes and MVPs going forward. What I've added to this is the digital aspect, and there's a physical aspect if we look at cars, and there's also manufacturing and components. There's a business aspect, also the economies. They all work at different clock speeds. So the example is this: to design a physical object for the next generation car in F1, it takes about a year. That they can say, here's my next engine, here's my next configuration. In that same time period, I can do 8 software life cycles. So now I have to understand, is it better to, what parts should be done through software, what parts should be done through physical. I also have to understand the economics of it, that I'm not making things that nobody can afford to do, or is it acceptable? So by combining all of these areas into a single loop that everybody can read from all those 3 different areas, I can clock speed my software decisions, my physical design engineering, and my business decisions across here, and clearly communicate and know that. So there's a very possible model that, from a technical point of view, it's great. But from a software point of view, it could fail, and I might have to pivot. Or from a business point, that's where it fails. So understanding how those 3 things work together and others is absolutely key, and this is a system that allows for it. Once again, I'm sensitive to time, so I won't map this to what we did with the F1 model. You're going to get this presentation, but we had specific steps in order to develop the fuel and the engines that we're looking at here. What's absolutely key is to be able to move your stakeholders from confrontation to collaboration. How do they work together? How do they get along? And it's always a combination of citizens, government, and industry. And it's about diplomacy, and its ability to communicate, and its pain, right? So how do you talk to the government? How do they approve something? How do we come across it? But we always have these dynamics in everything that we do in life, but you have to get good at this in order to succeed. So we'll talk a bit about that. And this is where it gets really, really interesting in my mind, especially as we look at the idea and the role of AI coming forward. So we call it live enterprise, or I call it live enterprise, because it's continuously moving. And there's 6 strategic objectives, there's 4 outcomes, and there's 4 foundational components. I limited my universe. I didn't want to have so many things that I had to look at that I would never get anything done. This is enough to get that. So from a strategic objective, I break my problem into these 6 areas. Agility and speed, how responsive the system is, how networked it can become, what's the velocity of ideas. So what that means is that not just how many ideas I have and how quickly, but as I work on this, I should get quicker and quicker as I do it over and over again. So there's a natural velocity that I have to account for in my equation. What's the platform I'm going to use? And how do I get to extreme automation eventually? Because that's my ultimate goal. I just want to get efficient, efficient, efficient. So the operational outcomes that I target when I design for my system, they come under what we call quantum organization. So micro-enterprises, being agile, product-based, hyper-productive collaborative teams, rapid experimentation, anytime, anywhere working. That's one of my things that says if I'm going to do something, does it check these boxes, or can it check these boxes eventually? The perceptive experience. What's the experience of the employees in this case, what I was working on? How customer-centric is it? How much computational design adds value, and can I increase that level through here? What are the memorable, magical moments that took place along there that really attached to individuals to stay with us? I can tell you I run a lot of, not a lot, 4 times a year up at MIT we do these hackathons that we insist that we give a subject, a challenge, and you have to have something mechanical, something software, something business that has to be explained. It starts on Friday afternoon at 2 o'clock, and it finishes on a Sunday afternoon at 2 o'clock, straight through. And we put the machine shops in place, You have teams of 4, there could be 100 teams out there, and they have to solve certain things. They could decide to sleep overnight there, or they could go home, whatever it is, but at the end it's a competition with prizes. And we see lots of ideas that come through here. And what happens undoubtedly every single time is the original idea that they do when we say, okay, is it technically feasible? Is it going to economically be viable? And will anybody use it? Are the 3 questions they have to answer with what they produce? They always start out, and then about halfway through it, they'll say, this isn't working. The money isn't there, the technology is not going to work, whatever it is. And then we go back and they say, all right, you need to resharpen your idea. What could you do without? What is it that you must have, and what is it that you want? And you have to do this. And what it does is it causes you to think, what can I live without, or how do I solve something smarter as an engineer? And what happens is your design actually gets better, because now you're really looking at what the core truth principles of what's happening. And if it doesn't hold up, and you see a lot of failures, it means your idea wasn't strong enough. Then it wasn't a good idea, because it's not feasible if it doesn't hit those markers. So those magical moments are really, really important. So in this case, if I'm doing smart buildings, what I was solving for is I'm reimagining the workspace, which is a big issue now. Do people go back to cities? Do we work remotely? It's the right timing for these discussions. What's the human-machine teams? One of the problems I'm having right now is if I'm looking at a workforce and I see this row of 6 students right in front of me, and you're a team, 2 years from now, is it only going to be 3 people and there are going to be 3 AI agents sitting here that are fulfilling that? Is it going to be 2 robots, 2 humans, and 3 agents? Understanding that balance are things that we're starting to look at, because that's what companies have to predict what their workforce looks like. That's the world that we live in. That's what you're going to be solving for. Responsive value chains. So I have to get along with others. They have to understand what I'm doing. I have to understand what they're doing. So I have to have the sense and understand the process and the response. I have to have shared sentient principles. What do we have common goals, morals? Do we not just do we like getting along from a business perspective, but do we agree with what we're both doing? What are the routines? +1. How do they change your standard routines? Process reimagining. How do we take that? How do I unbundle things and rebundle them into new configurations? And how do I create a resilient supply chain that's going to survive all of these changes that are constantly happening? And then intuitive decisions. We create knowledge graphs of how knowledge travels in a system. We labeled it a digital brain, and that's what we're now calling AI, but how do we get closer and closer to neural network decision making? Maximum intuition, minimum interventions. The more I can reduce the amount of interventions in a system, the quicker I go, the less risk I have, and the less time to get there. Edge-based AI. An example of edge-based AI is this. Who can tell me the #1 users by country of using AI? Somebody take a guess. #1 country in the world that uses AI?
USA?
No. Somebody else. Who else?
China?
No. One more guess.
India?
Excuse me?
India?
Yes. India, 89%. So you're leading the world of use of AI. Now, the second part of the question is, what percentage of servers do you think India has when we look at all the servers in the world for AI that are in India? It's 4%. So you're the highest users of AI, but you only have 4% of the footprint of AI. That's actually a good thing as far as I'm concerned, because you don't have the carbon, but you also don't have the control. And it's obviously changing right now. You're hearing a lot about this build and how to account for it. But you're using and leveraging the power of AI without having the expense of building the servers for now. Eventually that'll change, but it's a good thing. So this idea of you're an edge-based area. You're taking the edge of it, you're using it, but you're not having the investment of actually having the data servers here. It's really interesting to me. And then you have to be able to explain it. Who understands AI? It's not just you as a technical person, but why would people trust it? Or what gets to the point when AI is already talking to AI and not even talking to a human? So how do we explain what's going on and what's happening? And how much do we need to understand? And we also have to have instant simulations take place in order to understand and see what's going on in the system here. And then in the bottom part, the foundational components, we have to be able to design to constantly evolve. I talked about the double neutrality as an example. So as we change, how do we design so that our system allows us to constantly evolve and change? We want to have a digital runway. We want to know what's coming next. AI, quantum computing next. Quantum computing tied with a robot. Photonic communications on low orbiting satellites. Whatever that next wave is, we need to get some idea of what this is and how we're going to account for this. Hybrid talent. It takes many types of talents in order to pull these solutions together. And we want to have micro-change management. One of the biggest challenges in the world is, how do I have change happen? It can't be a big bang. You wake up one morning and suddenly the world's changed, and will everybody start doing it a certain way? Organizations traditionally put these long plans in that says, we'll do this, get this goal, we'll change, we'll do this, we'll get this goal. It doesn't work that way. If you're working with a responsive, active system like this, your change has to work in the same way. So, a modern organization model. You've got customers, employees, and partners up on the top level here. What you want is rapid innovation, you want rapid propositions, and you want rapid products that are happening across here. They need to be networked and they need to be connected. You want to be able to do things with small teams as quick as possible, but you want to have collaborative creation so you have these results coming across here. And when you do your data systems and your underlying infrastructures and digital backbones, they have to be architected in order to account for this. So it's all a complete picture through here. Gen AI, you can look at it a bunch of different ways. So we're talking about AI, machine learning. We're now talking about agents. We're talking about agentic. It really all boils down to this. So I teach AI at Cornell University, write a lot of the courses there, and we've been looking at it for about 15 years. And what we've determined is it's really about what we call psychometric data. So the idea of cognition, preferences, decision-making styles, and motivations. When we hear about prejudices or biases in our AI models, as we start to do this, this is what results, right? It's got to be trained models or understanding how culture works in there. So it has to do with psychometric data coming across here. We need to have these what we call sentient indicators of how we can comprehend what's going on and how we train our models through here. So we can measure by personalization, we can learn from transactions, we can measure unique experience, we can measure outcomes. And ultimately, these become the experience that we end up interacting with across here. So we want behavioral data that's automatically captured to user experiences. We want to understand who performed those actions, when, where, channel, and refinement. The challenge that's coming up now, and it's just logical, what happens when a machine doesn't need a human to be a part of the interaction? That's ideal, right? People can be doing some things, I'm not sure what yet. It all depends on what they're working on. But this concept of AI talking to AI, if it's done properly, makes sense, but we still have to see what's going on, but it will change our experience. And there's already models out there. This gets a little bit more into the architecture. I won't spend time too much on it, but if you're a technical person, you'll get this more. So maintaining and stating those underlying facts, there's event gateways, there's knowledge graphs that we're plotting in there, and then there's aggregated data sets that we're using. We're using different agents, and then we're using different signal processors in order to achieve what I was showing on the other cross here. And ultimately, this becomes summarized intelligence, and it becomes, when you train a AI agent, has everybody done that at some point? They've used ChatGPT or somebody, and you're training to do something. This is literally what you're doing. This is what you're doing with prompts. And ultimately, you're coming up with these experience APIs and turning it into there. And this is where it's all heading. This is really absolutely key as you think about your future and you think about how to tackle these things. There are different kinds of learners. and it's kind of evolved through here. And it may not be as intuitive as you think. So, is anybody familiar with the T model? Okay. A T model, this very first one, says you're very deep in something. I understand a particular segment. I'm really good at pharmaceutical design, and I'm a product manager. And not only am I good at this, but I work well with others. I can work within an organization. I can work with the financial controller. I can work with the programmers. I have those skill sets, so I'm able to connect and communicate. So what happens to the individual that's actually not just good at pharmaceutical, but they're also good at computer science data? Now they have two skills, so they're twice as valuable. And once again, they can get along. You have to have these ideas. And what if you, through your thing, you get to be really, really good? This is you get to your senior people. They're now managing other groups. They have multiple legs, this end model, so they can really collaborate with this. So now I could be pharmaceutical lead. I'm also the data science person on all my pharmaceutical, and I'm also running the budgets for the entire group of that company, and I'm responsible for P&L. That is traditional models. That's if you were to join a company at the 0 level or come into a research institute, you got to get good at something and you get more responsibility and you get promoted or you get more grant money, you come across here. What the new model is showing, based off of what I was just explaining, what is of high value is now Z models. So what the Z model says is this: it's more important to be able to learn something and unlearn something, and then learn something again, because it's always changing on you. Because if you don't unlearn, you're going to constantly repeat what you do best, and you freeze in time, and you'll always look at a problem the same way. And it will not allow you to be effective in the world that we are in right now. So this understanding that says I can quickly learn most things, I have things that can help me learn that. I still have to be an expert. I have to be very good at learning. I'm able to execute on that. And then, you know what? I have to relearn again and continually do this cycle in order to make this model work forward. And it's when you fill your organization with these kinds of individuals, it's when you have organizations that are what you see at OpenAI, or what you see at Google, or what you see at other companies, because their individuals are able to constantly relearn and adjust. And I'm beating this one to death, but it's so important. Almost done here. So we have different layers that we look at in the system. There's this interact layer that we know you're going to interact with employees, customers, partners, certain things, communities, and marketplaces for this to work. There's this process and serve layer, so we're reimagining the processes, the business processes. There's business services, there's observability, there's collaboration services, there's orchestration services, where how do all things tie together, and then there's constantly looking at insights and what are those action points. And then there's an intelligence layer that allows you to act, to know what's happening. Enterprise knowledge graphs, this digital brain sentence I just explained. AI platform and services in today's world, though I can easily write quantum in there. Process and interaction observability. How do I know what's actually happening going across there so I can adjust? And how do I provide the nudges and feedback to constantly improve the process or perhaps stop the process going forward? And then at the IT level, this digital runway about the shared digital infrastructure. I have to have knowledge management. I have to have a technology platform. I have to have playbooks about processes. I have to have these systems of the data ecosystems, and I need to have the resources and talent pool, because if I can't do this digital runway, I can't work with anybody else. And therefore, I won't get any exponential gains. It doesn't be any good to be on an island that you're the only one doing it as a company or as an organization if you can't interact with other companies and organizations. It doesn't mean you can best, I can guarantee you, you can build the best rocket ship in the world, but if nobody else can launch it or use what that rocket ship does, it's useless. It's better to have an inferior product that more people can use. So understanding that digital runway and getting along is absolutely vital. We talked about micro change management. So instead of saying, year one we're going to here, year two we're going to get here, and then we'll see what we need to adjust, No, it's a constant cycle of checking where you are and making those Z-learning adjustments as you go across here. And this is studies we did up at MIT to see what would be the effectiveness. There was the older model, which a lot of groups still use. It's called an S-curve. And is anybody familiar with S-curve? So this idea, it's very simple in your mind. You start somewhere, you get better at it, and then it doesn't work as well, and then you create another S, and you kind of climb the ladder. And that's the traditional way organizations think about change. I complete an S, I get on the next S, and I get on the next S. This is more of a intentional fast sweep, and I have these feedback loops that are constantly happening at shorter bursts of time so I can make changes much quicker. Now the risk is you don't get enough data to make the right decisions, and you have to account for it. But when we ran our tests on this, we actually found that developing certain relevant prototypes at the beginning increased the percentages of success, more prototyping, but not death by prototype. And then determining what was significant and what was standard in the prototypes, how they could be simulated into the models very quickly, and how full adoption would take place. So when we changed the culture, we talked about most of the things that we tried, we said it had to get done 6 to 8 weeks. And if you were doing it longer than 6 to 8 weeks, you were taking on too much. You didn't break it into a small enough system for us to learn. Too much time spent and not enough gain for the value. Now there are exceptions, as there always are, where something might technically take a longer period, but we rarely would okay anything over 12 weeks. And we would just say, it's not solving everything, but it took enough knowledge for us to make decisions going forward, because if we didn't follow these, a project could go great, but nobody would end up using it, nobody would understand at the end, or we didn't understand the speed of change. So that's really what it is. This stuff is honestly pretty complicated when you do it in practice. It's the organizations that you probably read most about, the Googles, the Metas, TikTok, they all use these processes as they go forward on here. So that's the end of my part of the discussion here. I know that we are 10 minutes over. That's not too bad because we started 15 minutes late, and I know you have classes, but I'm willing to take any questions, any thoughts that you have, feedback, anywhere that you want to go back and discuss a little bit longer, right? It's a lot to take in, I think, but somebody's got to have some questions to make time here, so be brave. You buying this? Do you think this is bullshit? I mean, tell me. I'll pick people. Okay, one in the very back, since you're sitting in the back, so I'm going to pick on you. What is double materiality? Okay. You with your arms sitting folded like this right here. So what do you do? What's your major? What are you focusing on?
Actually, I am working on hybrid microgrids.
Okay.
DC.
Does any of this apply to what you're doing? Can you find a connection or not?
No, actually we can include AI in our control systems. So that we can work on.
Mm-hmm. You on the end here? Yeah. Why can't IIT Kanpur become net neutral in 4 years? What's keeping it from happening? And don't worry, it's being recorded, so everything you say, everybody will see, so don't be nervous.
It takes more energy to operate and
Okay. What is it that you could do as an individual?
first we need to know like efficiently. We have to think a process like to have a vision what to do efficiently operate the steps, and then definitely we can achieve. But so without any goal and without any vision, definitely we don't know what is the end product.
Right, right. So it's having a vision. I mentioned it took 7 people to basically run this. Now they were paid and they had their job, and every day, you know, they had their goals and a manager to do this. It doesn't take a large team, right? And we are going to be running, as I said, 4 pilots between now and October that should result in dashboards, and it's going to be following these models that I'm showing you. So the Kotak School for Sustainability is going to be one of the buildings that made sense. So there's going to be solar, renewable put there, there's going to be metering, there's going to be interventions to understand the carbon footprint, and there'll be dashboards. There'll be 5 residences that teachers and professors have that will also be metered to understand not just energy, but looking at water and waste at the same time. It's very good. And we're going to take one of the dorms, put in 15 meters, and also look at that to understand the difference through there. We're going to say those are our starting points. And when we talk about being efficient in a system, we define that. And one of the questions said, I have 140, somebody told me we have 140 meters sitting in boxes. I said, great. When did you get them? 2 years ago. And I said, they're still in the boxes. And they said, yes. And they said, well, why are they in the boxes? Well, we're doing the research to measure the meters, to make sure they're accurate, where they should be best be placed. I said, how long have you been doing the research? They said, 1.5 years. And they've yet to put up a single meter. Right? So I said, make the problem smaller. Because one of the big issues that was real was saying, how do you hang 140 meters? It's difficult, the labor and everything else. So I said, statistically, and it's not that hard to find out, that if you can take 15 meters and get those installed, you'll get the same amount of data veracity within a margin of 1% difference as if you have 500 meters. So let's just get 15 meters on and get those working. And they said, we could do that with a team of 5 people in over 2 weeks. I said, okay, you just committed, we'll give you an extra month. So when I come back in June, you're going to have 15 meters up in the buildings. They said yes. So we're at least going to start collecting data. Just have to open up one of those boxes, not even empty completely, and they are literally going to go in there and attach to the wall and do this. So there's ways of actively doing it, but we don't want to do it in random ways. What I'll be working on with a team of people is that systems design to say what falls next in those loops and waves, so we can do measurability. At the same time, we're going to be building a pattern of governance to show that things are getting done and that they're measurable. The last point that I'll leave you with, when you think about decarbonization, when you think about these areas, what I mostly work on is smart cities, green industrial cities. So how do I look at a city? So look at Kanpur, for instance, or Delhi, and how do you start to make these things happen? And there are basically 5 points that I look at. 4 Ds and 1 R. First point is, it's about decarbonization. Don't ever lose sight of that. The second is democratization. It's just not up to a few people. Everybody's not bought into it, or if you don't have a wide variety of talents, you need to democratize. You need to do the technologies and what you're doing so that most people can participate that are going to add value. The third one is digitization. A couple of years ago, that would have been the internet. Now it's AI. The future could be something else, digital twins, whatever it is. But digitization makes it democratizable, because if people can use digitalization, just like you do things on phones and your apps, you can create an app that causes decarbonization because people are participating, or you can read a system better. Digitization is kind of that thing that enables that. The fourth point is you need to demonstrate what you're doing. That's why I show videos. If you can't tell a story, no one's going to know what you're doing. And that's so important. You have to constantly remind. So one of the things that I will start doing is once a month you're going to see an email announcement come out of what has happened on this campus towards sustainability. Sometimes the stories will be good, sometimes they won't be good, it'll be big, it'll be small, but once a month you're going to see something now that something is happening or somebody's doing something. We have to constantly tell the stories. The fifth one in the real world is remonetization. Nobody ever lets you do something that's just going to cost something. It has to somehow have a return on investment. And there's a return on investment socially that will only take you so far, and it's the right thing, but it also has to have a monetary association with that. And there are models about how to do that. If we had more time, I'd explain that, and hopefully I'll come back soon and we can get you in again when we talk about it. But unless it's profitable, no one's going to stick with the program. In my lab at Carnegie Mellon, it's the only thing I have written on the wall that sustainability must have an ROI, and I have a dollar sign next to it, or I know it's never going to last. It'll last a year, and then it'll go away. That's like losing your grant. So those are lessons that I've learned. Anyway, I want to thank you for your time. I know you spent extra time here. This is only the second time I've spoken at this institution. I spoke a couple days ago on something completely else. Would love feedback, either somehow through your professors or whatever, but I appreciate your time, and I'll hang around for anybody if they have questions they want to talk about separately. So thank you.